Hello guys, welcome on this new recording, continuing with the integration of the ProLand in the NervLand engine. Today we will in fact just start with the normal producer, and what we have here are actually working results for the normal producer, so I can just demonstrate that right now. Okay, so here we are. The terrain with elevation in place and normals used to control the color of the terrain itself. Actually, the light source here is considered to be somewhere, I guess somewhere like here. And you see that this face of the terrain is receiving more light than the faces on this side, for instance. And okay, so this is it. Basically, we have now both producer providing the tiles, and you can clearly see, for instance, if you look at far away mountain here, that we're going to get more details the closer we get to this mountain. So you see here we have less detail and a bit more, and then more, and so on. I think currently I'm using only 9 levels for the terrain, but this could be increased further. The thing is, I just realized that the demonstration that is provided in the ProLand is using a terrain of 50,000 units size, and it's going as far as 16 layers, I believe. Let me just check that, but this is it. Yeah, size 50,016. And you need to be careful when you want to display that many levels, because if you were to use a smaller terrain, for instance, and still keep 16 levels, what could happen, I mean, I tried that and this did happen, it is that you're trying to display a relatively small quad, and you have a very high number of, I mean, a relatively small terrain, and you have a very high number of quads on this terrain. So you are actually filling your cache immediately, and you don't have any remaining unused tiles in your cache, so you get a crash in my case. This is also another issue I need to deal with. You see that here, for instance, I'm not displaying those tiles anymore, and this is definitely because of the curling process with the camera frustum. And the point is, this curling currently is not really taking into account the elevation that you are using to displace the vertices, which is a problem because, for instance, here I'm pretty sure it's actually considering that this tile here is way lower than what we are actually displaying. So if it's way lower, it's not even in the camera frustum, so it's not necessary to display it. But the truth is, we actually need this tile, because then we're going to displace the vertices. Okay, so still a few issues to fix like that, but what I want to do right here now is just add a small option here in the IMGUI control panel to be able to toggle the display of those, you know, the coloring that I'm doing for the quads to actually show the quads. So I want to be able to toggle this feature on and off. So let's try to do that. Where we would go to do it? Construct GUI, I guess. Yeah. So let me just try to prepare some of those, I mean, just one entry needed here. So what we're going to do is just to add this entry to display an additional checkbox. And Then what we want to be able to do is to access the data from the terrain node here to be able to specify in the uniform buffer that we want to toggle the display of this quad grid, visible or invisible. So for that, in the terrain node itself, I'm adding this symbol function to get access to those terrain info, which is in fact a structure representing the buffer that will be sent to the GPU. And in there, I think we had this grid variable, for instance, where I'm using only the first channel, so the X channel, and I could maybe just add, well, a usage of the Y channel, for instance, to provide this flag. So in the entry here, once I have performed the display, I can just say, okay, get the infos. And let's say t-infos grid, I think I can use y, equal, if this is true, we just set this value to 1, and otherwise we'll set this to 0. Then, in fact, this buffer is going to be sent on every frame when it's time to render the terrain node. So we don't really need to deal with the update of the buffer itself anymore. It's going to be updated as expected. So I think this is it. Now we just need the part where we deal with what to do with this flag in the shader itself. So we're going to have a look at the displace elevation with normal shader. And here we have the grid. So let's see, what do we use that? Terrain grid X, okay. And for the display of this pattern, it's dealt with this part, which means we need to pass the information from the vertex shader to the fragment shader. For that, we have the output here. We already have the blend value, which we were displaying at some point. We could just override that because we're not displaying this anymore, but for now, let's just add another entry like show grid. Oops. Oh, come on. Okay, I'm in English. Sorry about that. And we need to set the value for this show grid parameter. And we need to read that from terrain grid Y. In the end, the value we'll get here is going to be either 0 or 1. So next, here we're only going to color this red quad if the value is 1. So to be safe, we're just going to check show grid them if it's bigger than 0.5. In this case, we apply the coloring, otherwise we do not apply anything. That's basically all we need, right? Building completed. Yes, but no. Something I'm missing here. What is it? Maybe I'm actually overriding the full grid value somewhere. Yes, when it's time to actually update the full terrain info structure, I'm using this set function to set everything on the grid, which is going to override the latest value I set for the Y component. So we can't really do that anymore here, and we need to be more selective. And the default value is going to be 0 everywhere when you construct this buffer, and now all you really need to do is set the X component. Something like that should do the trick. Let's try to build again. All right. Now we have the quad pattern, and we can disable it properly. So cool. And that's basically all I wanted to do here. Yeah, it's very disappointing to still have to fix this missing quads issue. So I should probably look into this next. But I'm not sure we can see that clearly on the recording, but it's really visible when you look at the screen here that the part that you have close to you are much more detailed than the part that are far away. So that's cool. It's working pretty fine. And in fact, with that, I believe we have the first terrain implementation working. Oh, not ProLand. So this one, we are basically achieving the same kind of display. I mean, there's still one other issue here, which is related to WebGPU itself, and it's the fact that for the elevation, for instance, here you're supposed to rely on linear filtering and still use float32 values for the data itself. But when you are in WebGPU, you don't have filtering available for float32 textures just out of the box, which means we can get results like that. Because in the shader that we're using for the display, we're going to decide which color to use for the terrain. Where is this? It's this part actually. You decide which color to use depending on the current elevation that you have at the fragment location. But to do the sampling, you have to sample the elevation tile. But since the elevation tile is a float32 texture, you cannot use filtering on it by default. And this will give you this kind of result where the filtering is not applied. So yeah, you would otherwise expect to have a straight line because the computation is done per fragment. I guess one option here is to try to enable the float32 filtering feature. I'm just wondering if this is not going to break compatibility. I don't think it would break so much, but I need to investigate what exactly are the implications for that. But anyway, apart from that, pretty happy with the results so far. And next step then would be to move to the next terrain example, terrain number 2, and this one is mostly going to introduce display of the Earth shape itself. So we're going to move to using 6 terrains together, and apply the appropriate deformations to get the sphere shape. Maybe there's still some fun here to do the implementation part. We'll see. Anyway, this was just a quick demonstration, and as usual, if you have any questions, just let me know in the comment, and otherwise, we'll see you next time, hopefully with a spherical planet, or maybe before that, we'll see. So, have a nice day, bye bye.